Hey folks, so today we'll talk about, uh, as usual, philosophy topic, and it's about the models. Because, in my previous video where we talk about the simplicity in software design, we was talking that, your simplicity is depend on the team, on the context of the team, on the domain, and many other things. But success of simple design actually is the nice model that have the lower cognitive load. And in my another video about the software architects, we was talking that architects actually map the reality to the model, where we could reason about the architecture, take the decision, and he translated this actually mental models to the different people on different level in the organization. So somehow model are crucial, and we're not talking about machine learning model. Don't be confused. We're talking about some mental models, and I don't want to go deeper to the philosophy or epistemology and talk about the knowledge representation, and if knowledge actually is really in your head, but how the brain is working actually, that you have the model or you have the representation of the things of the people in your head, and maybe they could differ from the reality, and it's a main challenge that you know how to build a model that's simple enough to reason about the things and lower the cognitive load, but in the same time preserve the key features that actually important for the architecture. It's a main challenge for the architects. And we all know this old statement that all models are broken and some of them are useful. And actually, it's described the best the current state of models in general, that we could not just map everything. It doesn't make sense. It's have a lot of noise. It's have a lot of challenges, and we could not even digitalize a lot of objects from real world. But we could have tried to make something that makes sense in a current situation for the current requirements. And we really need to know that when you create the model, it's just a reflection of some state of reality, and then the time evolve the reality, and the model could be outdated, and we need to take care that our model up to date, not just the code base, but our understanding what we are doing and why, and if requirements actually it's up to date. And so it's yet another thing that the reality evolve over the time. Models needs to be evolve over the time together with the reality, and for sure. And yeah, and it's not only the time is our enemy, so it's a lot of things that maybe we get some new understanding, or maybe we really have some wrong perception about the thing, so we should also correct the model. And sometimes they're not useful anymore, and sometimes we made just bad decisions, so we just need to revisit the models. But we always need to remember that the map uh, of the some area is not the area itself, and the models work like the maps. Yeah, so uh, things could change, be changed, and we need to be ready for this change, but we still need to find some lower things that we could really focus, and the models help us to find the focus. And the good models are simple for the cognitive load, but it doesn't mean that you need to use some simple things that everybody knows. You could prepare not only the model, but the team to understand this model. For example, the small talk, it's super simple language that you just have the object and message passing, and when you learn in which orders the messages are sent to the model, you already know entire language. and it's super cool. But if you're talking about some complex domains, for example, edge compute or the artificial intelligence and all of the things, you do not expect that you could grab the students from the university and they will do you the machine learning research. Yeah, you expect the proper people that will do the job. So that's why we needs to build not only the architecture, but we need to build the builders together with the architecture. And what's more important, we need to involve the builders to build the models because it will be much easier to sell. It will be much easier to understand and buy when people really contribute to this process. So the models actually are the cornerstone of the architecture, software design, and software development. And we have a lot of frameworks that help us to build the models. For example, the domain-driven design is really good framework that operate with the objects, entities, and all those things, and it's cover a lot of business domains. So you could build a lot of business applications on top of the DDD. And we could say that any kind of software have his own model and domain, and we could always split to the domains, and then we could make the even storming events and all other things that help us to build the mental model that everybody understand. And yet another useful things about the model that we could take the model is not the code, and go and talk about the model with the products or the business people or some other guys, and we could have the layers in the model that the top layer are closer to the you know business folks, and the lower layers of the models are closer to the developers. But the beauty, for example, of the Smalltalk that I mentioned and some other languages, that you have no way, you practically have no language constructions. You need to build the domain specific language that operate with the domain models to build the program. So and your code get somehow the manifestation of your domain design and your model. So your code reflect the domain, and it's quite good. So the DSLs, it's yet another good instruments to translate the models that we designed together with you to something that we could touch. Yeah, and it's a lot of interesting works in functional architectures and algebraic models and algebraic types where we translate the DSL to the functional programming and functional design. Not always pure functional programming are useful. Sometimes it's complex and it's required prepared developers, but sometimes modeling in terms of the algebra is really useful, because what the algebra is, it's not what you remember from school. It's more about the objects, yeah, a set of objects and set of operations on the objects, and then you regulate what kind of operations are feasible, what kind of results of the operations are allowed. So actually you build in some kind of formal logic of the operations on top of the objects, and actually it's what every architecture somehow and every domain is doing. So the algebraic functional architectures actually could help you to translate the models to the code with the minimal amount of abstractions that they give on top. So, just to summarize that good models are the key for the simple software design. All models are broken, some models are useful. Models should be changed to be aligned with the reality over the time. And yeah, and we always need to validate if the model is correct and reflect the good things, and if a model is useful to make a decision on top of it. If it's not, we just needs to change the models. So that's all, and see you next time. Choose.